height?
Max height. It's my height, and it's the maximum height. Yes.
That's like a wonderful coincidence. I was hoping that was an intentional pun. I'm very excited to do this on the podcast, what we do in normal life, which is like call each other and be excited about all the technological things, and then like shout and wave our hands about how amazing the world is going to be in the future when we actually figure out how to like use and do all this stuff. And then like all the various ways in which 1 + 1 = 3 when cool tech stuff comes in.
Right, yeah.
But since this is your first time on the podcast, which is my massive oversight, I feel like a quick intro and like your background would be helpful, so people can get a feel for where you've been, what you've seen, what you're into.
Yeah, so I work at a startup called MashGen, and we make a visual self-checkout kiosk where you don't have to scan items barcodes one by one. You just place all your items down, you tap your phone to pay, and you go. It's that like super easy checkout, basically. And that's my day job. I have also published a book since 2012, and I run an investment fund on the side.
Still doing that investment fund's you've been at that for a while. Is that what is the like focus of that?
Yeah, so it's a long only fund, mostly public investments. I mean, that's how it started, is just kind of what you would call a hedge fund, a little bit of like options hedging. And over time, I've kind of private investments have creeped into the strategy. It's mostly kind of your typical long term, value investing. That's the majority of the actual position sizing. But then I also do lots of different kind of, special situations, quantitative strategies, things like that. So it's a little bit, it's similar to my own style. It's a little all over the place.
Yeah, that is like less tech focused than value focused, though, right? I'm sure there's some overlap. How would you classify that?
Yeah, but when you say tech focused, you mean like in terms of the companies itself, or?
Yeah.
Yeah, I mean, it's definitely not tech focused per se, although like similar to the private investing, I think it's slowly over time gotten more and more on the more tech kind of side versus the more what you would think like of Warren Buffett style investing, where it's like, it's definitely not anti-tech, right? I mean, he's invested in multiple tech companies, but it's more of like invest in things that are not going to change, in 10 to 20 years, or that's the goal at least. And yeah, I think my style has gotten a little bit less like that over time. And I've been a little bit more willing to take on, I hate the word risk, but the uncertainty of whether something is going to play out.
Yeah, specific technology. I like the, I think it's a biologyism that like saying there's a tech industry is like saying there's a physics industry. Like every company interacts with technology. It's just to the extent that they acknowledge it and focus on it.
Yeah. Oh yeah. So, I've gotten
that's fair.
In discussions with people in the past where it's just like, hey, that's not a tech company. I'm like, well, not technically how it's defined. Yeah, but it's like, it's a tech, and every company is in some way a tech company. I mean, if you operate this old industry, manufacturer, a cabinet maker, it's like, okay, you wouldn't go around calling yourself a tech company, but you're using technology, and in a lot of ways you have to keep up with the latest like technology and how, processes and how things are done, how other competitors are doing things that might disrupt your business in some way. So, if you go into business thinking that every business is a tech business, I would think you'd probably be better off than assuming it's not.
Yeah. That'd be an interesting like gradient to look at, like what is the range of specifically cabinet making companies? Like what is the least technical cabinet making company in the world, and what is the most technical? Like that'd be a good illustrative blog post probably. You were in computer vision way before it was sexy. So when did you start at MashGen? MashGen's been a computer vision company since like forever. Like you guys were real early to this, which I think is probably a unique perspective on the industry and the tech.
Yeah, MashGen started. It was first founded by my friend and one-time housemate, and he's been in computer vision, like you said, for literally forever. I mean, he did computer vision at Bell Labs, Toyota Robotics, doing like vision for robotics. And when he started MashGen, I think it was just him, of course, at first, 2013, and it was, what you'd call traditional computer vision. So computer vision today is using these huge neural nets, right? And that's just like it's got this very similar goals, but it's a totally different method than what they used to use. The best way I could describe it is, as probably most people know, like all images can be broken down into numbers, right? And, if you have an image that's sized, 100 by 100 pixels, then that's 10,000 pixels. And then each of those pixels is red, green, blue, some, combination of that. And so you have that image is just 30,000 numbers, right? And so traditional computer vision was more like, let's just say if you wanted to determine if something was an apple or an orange, that's an easy example. It would be, you're manually programming things like if statements that says like, hey, look at all of the pixels of these images. And if on average, this image has more red pixels, then it's probably past an apple, past some threshold. So that's an example of traditional computer vision where you might apply some Photoshop-esque like filters to it, like turn it black and white and apply some contrast filter to it. But you're basically kind of manually thinking of like, oh, how would I break this apart and determine, what's in this image? I mean, actually, I should have stepped back. Like if people don't understand what computer vision is, it is what it sounds like. It's, helping computers understand what they're looking at basically. And so yeah, that's traditional computers. And that's the era that kind of machine was originally conceived of, but it was at the very beginning of this huge switchover. And I think I'm not an expert on the history, but it started right around kind of 2010 when these neural nets have been around for a very long time, but when deep learning really started to kind of take off. And we don't need to go into the super detailed. One of the biggest reasons, as many people have seen, is GPUs and just like how powerful they've gotten over time, and using those for compute power to like train these networks. Whereas in the past, in the 90s or the 2000s even, it was just too computationally expensive to train these neural nets. But anyway, starting in this like 2010-ish timeframe, that's when neural nets really started to kind of take off as a tool.
So this approach, the software approach, had been around, right? And it's just the hardware caught up to make this software approach more effective?
A little bit of both. It was on the hardware and software side. So the concept of neural nets had been around for a long time. I don't even remember, like the 60s or 70s is when they were, and they were used throughout then. They just were, it was more honestly of like an academic, like theoretical thing than like practical application. But I think right around that same time, some new ways in terms of the actual software and the algorithms of doing these, and not just using them on GPUs, but just how the models and algorithms were structured, basically. And we can talk more about that later. But it's like a lot of those changes are going on right now with all of these AI art models and diffusion models and such, where they're still in neural nets, but they're different. It's how the neural net is structured and how data is interpreted and things like that. That was a little bit different. And so that kind of really started to take off during that period. And there was there's something called ImageNet, where it's like, it was basically benchmarking how accurate image models were at recognizing images. And they're, I think it's probably changed now, but in the early days, it was a specific, like, this is a set of images, and we're going to, test all of the models on the same images and like how accurate they got. And they even tested, humans like on that model. And, even humans were far from 100%. I don't remember the numbers, but it was like, humans might only be, like 85 to 90% in like quick identification of what's in the images. But right around that time is when the model finally kind of beat humans. And similar to some of the other areas this is happening now, that was a big threshold crossed, and it kind of proved at that time that deep learning was the way to go, basically. And from there, the models and the hardware scaled up, and it's just gotten better ever since.
Could you give us like so I hear sort of neural net, deep learning, and machine learning use what sounds like interchangeably. Is that reasonable? Or should we define those differently? Could you kind of like frame that out for us?
I won't be the best person in the world to define them, but machine learning is the broader like subset of all of them. That's it. Okay. Machine learning kind of includes statistical analysis and stuff too. You could say machine learning is a subset of AI in general, but pretty much I think everything people do now within AI is considered machine learning. Within machine learning, you have neural nets, and that's just what kind of model you're using to predict the what's in the images. And deep learning is you could almost use as analogous to neural nets, but deep learning is more of just like a neural net could technically even be it's a stacking of layers of neurons, and a neural net could technically only be 2 layers. You could consider that 2 or 3 layers a neural net, but that's not really deep learning. Deep learning more refers to these bigger models with like many layers and thus many more, much more like complexity. That's a kind of the way I would describe deep learning. Okay. If you want, I can kind of describe a little bit more about like how neural nets work and such. But yeah, that's and maybe like with that analogy, the thing that I'm left wondering is like, what is the analogy to a neuron? Is that like one function, and then you're layering a ton of different functions, and that increases like the confidence of the total system? Kind of, yeah, kind of. So a neuron is more. Let's see, a neuron is more less like a function and more like just like a number. It's like in an equation, your y equals mx plus b. A neuron is like a weight. So your classic kind of math, y equals mx plus b, like m would be a neuron basically. So if like that would be a weight. And so just to kind of maybe even back up a little bit, that's kind of what, in some sense, all machine learning is predictive statistics. People kind of, if you don't know what, linear regression is, it is what I just said. It's like the y equals mx plus b. If you plot 2 points, on a chart and draw a line between them, that's you predicting like, if anywhere else goes on that line, that's the prediction, right? That's the basics of linear regression. And that's as simple as you can get. And it just kind of scales up in complexity from there. I mean, for just linear regression, that's just one variable. So if you're trying to predict, the price of a house, right? And you collect a bunch of examples of how many, houses that have sold and how much square feet they have using square feet, that's using one feature. And you can easily just kind of plot just do the math by hand on a piece of paper for something that simple. Plot the linear regression and then say like, okay, it's, you have your average, it's this average amount per square foot. And therefore I'm going to predict this house is going to sell for this much. Now that's probably not that accurate because for the house, you've got all these other factors, number of bedrooms, whether it has a pool or not. And so if you wanted to, you can just start adding in those features, right? And that gets into like, a multivariate regression, and it starts to get a little bit more complicated, but still enough that you could do it easily if you wanted to in a spreadsheet, right? And that's essentially like, these neural nets are essentially just like very scaled versions of that. A regression is like one layer of a neural net, essentially, and a neural net's like you continually like add layers of that regression. And back to the image example, actually, you have like I said, an image is represented by all these numbers, and let's just say, one of the most simple, probably computer vision recognition problems you can think of is like, how do you tell if something's a square or a circle? Okay, so if you break those into numbers, what you're essentially doing is like you're feeding in those numbers on one end of the model, and on the other end, you just want it, there's a binary outcome. Is this a circle or is this a square? And so you're just reducing, let's just say like in the example I gave, you're 100 by 100 pixels. That's, if it's black and white, 10,000 numbers. You're feeding into this function, the model, and it spits out one number at the end of it. So it's essentially just reducing those 10,000 numbers to one number in these successive layers. And the way that works is like, again, this starts to get complicated, but like each layer is like a simplified way to say it is it's like breaking, it's it takes all those pixels and it's breaking it down more and more. So it learns kind of like, okay, this is what a line is. This is what a corner is. This is what a curve is, down to the, the last few layers where it's like, okay, the second to last layer might, essentially say like, okay, this object looks like it has 4 corners. And therefore the last layer says like, if it has 4 corners, then it's a square. And that's a simple example, but that scales all the way up to like, is this a dog or a cat? And, and that last thing is like, is this a dog or a cat? Yeah. And yeah, again, it's just like mapping all of those numbers, reducing it to a few numbers. And that's exactly what humans do, really. I mean, if you look at a dog or a cat, it happens instantaneously in your brain, but that's essentially what you're doing. All of this, thousands and tens of millions of bits of information, it's flowing into your brain. It's instantly, and your brain is reducing it down into like, either make a decision or what is this thing?
Yeah, I mean, it is, and we spent 20 years learning what's a dog, what's a cat. Like, you treat the machines, the AIs, like kids, and just like part of it is the complexity of the function, but or the network, but also part of it is just the sample size. I know there's a huge part of the boom in AI and computer vision has been benefited by just like the scale of things that we have added online, made available, made accessible, and like fed these things so that they can. It's safe to say like they are now writing their own rules, right? Like you can tell the function to teach itself how to distinguish a cat from a dog. We don't have to write, pointy ears, size, weight, colors. Like those are things that are kind of emergent from, hey, figure this out.
Yeah, exactly. And that's kind of, and again, back to that's one of the differences between traditional computer vision and now using neural nets is when you're training those models, those huge neural nets, and something like what I was talking about, like square or circle, that wouldn't be that, because it's not very complex. That neural net would not be need to be very big. It would only be probably a few layers, only, a handful of neurons per layer, and that's good enough. But the bigger the problem, the more the complexity, the more data you need, as you said, and the bigger the models. And yes, it will, in this training process, when it's kind of each of these neurons it's like going back and forth, like learning, basically. It's almost kind of like if you are familiar with the concept of a fitness landscape, where it's like the height on the landscape is how good the solution is. Like it's like traversing that landscape, trying to find the best, weights for that model so that when it's used, it finds the best solution. So in traversing that, it is quote unquote learning what these things are. Like you said, what does a leg look like? It doesn't know what, a leg is per se, but it kind of essentially learns those things over time.
Super interesting. And of course, like I think you get this from the Bottomless folks. They have the company that's like a Wi-Fi enabled scale, and it's just like, as a general rule, the more things you can make legible to computers, the more that AI can do for us, and the more that can be done by like really high leverage automated, like crazy machines. So I feel like the computer vision in general, the companies that I know of in the computer vision space, and you might know more, are much more like, they're very specific. They need to train to a specific data set. Like you're like, we are going to learn all of the items in this store at Mashgin, the items for sale, and we're going to be able to recognize all of them. Self-driving is kind of like recognizing cones and people and objects. That's maybe the most general. I know
that one's pretty general. Yeah.
Yeah, extremely general. Our mutual friends at Density are very like, recognize a human in a space. So these are kind of like getting verticalized, but it seems like they're going to get more and more general, or like cross boundaries more and more, maybe.
Yeah. I mean, with these much, much bigger models that are coming out, they are much more sophisticated. They can deal with much more, complex understandings of what is in the images. And so with those, I think you're right that it will be less verticalized, but I still think in the actual like industrial applications of that, whether it's Mashgin for recognizing, things for checkout or Density or whatever, I think those, you'll still get companies that are in those vertical spaces, but less because of the model and, how detailed, they need to know the model, and more just because of the actual application of it is difficult. And yeah, it's not like, Machine is not competing against OpenAI. Let's just say, OpenAI might be able to very easily, develop a model that can recognize the same types of items that Machine can, but that doesn't mean that they're going to all of a sudden, if they wanted to enter the self-checkout business, that they're going to be very good, because it requires a lot of customer knowledge, user experience knowledge, all that kind of thing. That is not, that's the model basically is a super important part, but it's not everything. It's not the biggest part even. But yeah, it is a super important key, and there's definitely a lot of data network effects. Like if you've collected data over time and you keep collecting it, that's for sure, in the business sense, a barrier to entry. And if you're a startup or whatever, even if you're one of the bigger companies, it's not as easy to come in and, snap your fingers and drum up the data. With sufficient amount of resources and money, you probably can, but it's some level of barrier.
Yeah, especially in the, I think like places where the data is protected, right? Like it's just expensive to collect self-driving data. So I know people talk about that as a moat that Tesla has, is just like recording a lot more road hours than others are able to get in, or where data is like the HIPAA compliance data, right? Like X-ray screenings, it's difficult to get huge sample sizes, but there are AI models that can train on X-ray scans and be like, oh, that's a dangerous thing. That's this. People train for years to recognize that kind of stuff. I was trying to think as you were talking of like, what are the jobs that humans do that's basically like taking in visual information and outputting a decision. It's like, that's security guards, that's radiologists, that's
a lot of things
drivers.
in manufacturing. The people there in manufacturing, even if they were using a lot of automation and robots and whatever, the people there, it's a lot of visual, like whether it's monitoring the robots or monitoring the quality of something, something at different steps of the way. It's like, hey, I'm just going to visually inspect this. So there's a lot of that in there, and that was a path that Machine once looked into. So
interesting. Yeah, I bet people have used Machine and not even realize it. Like it's in a ton of stadiums, airports, commercial sort of like kitchens and cafeterias as well, right? Which is the most common of your installs?
The most common now is convenience stores. So yeah, I should have said too that the machine is not. I say self-checkout, and that's what it is, but it's made specifically for small format stores, and so exactly like you said, convenience stores, airports, the kind of sports venues like food and drink venues at sports stadiums and arenas. Cafeterias in schools, businesses, hospitals, things like that. Basically anywhere where you'd go where you don't need a shopping cart, where you're like the extent of the items you're going to get, like you can carry with your two arms. So that's a good way to say it.
Oh, okay. All right, cool. So let's sort of examine the like transition between maybe how computer vision is feeding into this AI. Like, I feel like AI is having a moment this year, even though I'm sure there's plenty of people who would be saying like, yeah, it's been coming for 10 years. Like watch, the development of the chess playing things. And 5 years ago, everyone was talking about how like the ultimate is like the Centaur, the like human plus AI combination. And that's kind of where we are with like the writing stuff right now. Like Nathan Bashaw's new product Lex is kind of like, AI outputting art or language is like cool, but not sufficient without a human sort of head at the moment. Though it'll be maybe interesting to explore how that changes. I know both of us have played with kind of the text to image and there's like the reverse of the computer vision stuff you've been working on.
Yeah. Yeah. And that's kind of, I mean, it's more complicated than that. And there's a lot of changes in the models, but that's almost kind of what it is. Like I said, it's like if a neural net understands how to translate the numbers in an image to like, is this a dog or a cat? Then this is essentially just reversing it and being like, okay, well, what does a dog look like? It's obviously a lot more complicated than just reversing it. And these new changes in the algorithms, like this new way that all these text to image models use this thing called diffusion. And that's even a little bit over my head in terms of like fully understanding exactly what it does. But this again just kind of goes to show you that there can be innovations in these models, and that's hence the changes and improvements over time. I think there's hardware improvements as well. It's like these, particularly NVIDIA, GPUs have just gotten better, more built specifically for deep learning and stuff. So that has improved over time. The scale of the models has like drastically gone up. I don't remember the exact numbers, but I think it's like, they've done studies about model sizes, and, it follows, it's basically like the Moore's law equivalent. It's a lot faster than Moore's law. But it's like the size of the models are just on this like, crazy curve upward. And yeah, it's like, for the most part, to scale the models that big, you need more data. You need the equivalent scaling of the data. And so, yeah, it's crazy how fast it's making progress. And it's a little bit of the, you get all of these models coming out at the same time. Like, I'm sure listeners have heard of these text to art and image models that are out there, like DALL-E 2, Midjourney, Stable Diffusion is the open source one. And all of these have come out relatively the same time, or at least that's the way it feels, right? I mean, of course, the researchers have worked on it or similar problems for years, but I think one of the reasons why these all seem to come out at the same time is these changes, these underlying kind of improvements in hardware and such. But it's more than that. I think part of it is the kind of 4-minute mile thing, where it's like once it's done, people know that it can be done, and so like they work more to do it. Yeah. The others is that a lot of the stuff, even if the model itself is not open source, like the DALL-E 2 example, they'll come out with a paper or even just like a post on it, kind of roughly how they did it, and their model is based off of papers that people have come out with, multiple years ago potentially. And so if they point to those papers, then the other researchers can kind of figure out basically how they did it. They can try to collect some of that data themselves, and then they build their own models. So it's crazy. And then now that you've got the open source thing, people are just like have taken the Stable Diffusion model and just totally run away with it. And we've already seen, in a matter of a couple months, such like you've probably seen some of the crazy stuff they're coming out with, and I can't even imagine in a few years from now.
Yeah, I think that's it's also really interesting to seeing the specific ones come out, right? Like the visuals. I've seen friends who are like Nat Eliason was talking about. He's like, all of his blog posts are now illustrated by. He doesn't go like searching for stock images anymore. He just like drops a prompt into I don't remember which one he uses, Midjourney maybe, and uses it. He's basically like hired an AI as his illustrator in the last month. So I think it's interesting to think about the specific jobs that AI is getting like hired to do by people right now. I saw, I think it was Ali Abdal got access to Nathan's product, and he used it to write a whole tweet thread of like productivity hacks and tweeted it, and it went viral. And then like 2 days later, he's like, I have a secret that was written by an AI. Like, so like ghostwriting or collaborative writing.
And is that's what Lex is? It's like, it's, a text model kind of applied to AI, like assistant, like trying to help you write. Is that?
It's basically, so imagine Google Docs. It's like a kind of a cleaner, tidier, more designy form of Google Docs. And you're writing a blog post, and the function that the AI plays is basically if you get stuck, you just type like +++ and tab, and it will populate the next 3 sentences from GPT-3, I think is the model they use, based on what's already there. And you don't have to use it. It might not be factually correct, but it is like the AI prompt. And it just has a way of sort of like, you can agree with it, you can disagree with it, you can edit it, it just like keeps your momentum and juices flowing. As a writer, I think it's like really interesting. You can also do the same thing for counter arguments. Instead of like, hey, continue this document, it can be like, come up with counterpoints. It can also write, there's a function where it can create titles based on the body of the text. So it'll brainstorm like 10 titles for you, which is a great, I mean, it's hard to like sort of get variety and novelty yourself when you're just brainstorming topics. That's like a high energy task. So I think it's really cool to just see that augmented, it's the Centaur like kind of approach to it. And I think it's, it's not quite generate a perfect clean document as AI, but it being an input to a writer's process is an important function and a really helpful tool, honestly.
Yeah, and it doesn't, maybe eventually it will be, potentially be able to spit out this perfect document. But like you said, it doesn't need to. I mean, going back to like, just Microsoft Word decades ago, like that had a thesaurus, right? And it's like, it's just like that extrapolated, right? I mean, if you were like, hey, I don't want to use this word here, I want to use like a better sounding word, you look it up in the thesaurus and you change the word, right? And this is just like a super advanced version of that. It's like, how do I reword this sentence even to just like, this kind of sounds off or whatever. I mean, find it a better way to say this, or a more succinct way to say what I'm trying to say, because it's a little verbose or whatever.
Yeah. I think it's funny. The combination of these two is funny, because when you look at a bunch of stuff that like Midjourney or DALL-E 2 has generated, the only thing that's like, the two things that are terrible are, one, faces, and two, text. Like you could say like generate a Snickers bar and it would look pretty good, but it would say like Skinner's, Skuntley, and not even words or letters. But as a pure functioning writing device separately, it's really good. So I think seeing these things sort of like come together over time will be really interesting, as we take the best of each thing and combine them. It
could be different models too. It's like, it could be, a lot of the text models like are using a large language model like GPT-3 to, as the basis. And you can kind of, great thing about GPT is like, if you're using their API, you can kind of build off of that. And that's honestly, I didn't mention it before, but one of the great things about neural nets in general, just like other kinds of programming, you can build off of it. So it's, once the, GPT was crazy. It's like, I think it cost them, the estimate was like, $12-15 million to train that model, off of Microsoft supercomputer with, 10,000 GPUs. But you're not, if you want to augment that, you don't have to retrain that model. It's like a simple way to say it is you can you have this enormous model, and GPT's is 175 billion parameters, or like weights and neurons. But instead of retraining it, you're just kind of like adding the few last, you're adjusting the few last layers, which doesn't require, nearly, orders of magnitude, much less computing power to do. So that's a huge benefit to all these models. And you haven't really seen that happen. That's probably what these companies like Lex and then the other writing companies are doing. They use GPT as a base, as this kind of foundation, and they're adding a little bit, of kind of levels on top of that to specialize it a little bit in what they're doing. You see a lot of these kind of conversational / like assistant models that are probably doing the same. And we haven't seen that much happen with the text to image models, but I think you'll start seeing that really quickly. There's already been some papers and some experiments out with like Stable Diffusion on doing that. Like if I say, if I go into my DALL-E prompt and I say like, show me Eric Jorgensen, riding a horse on Mars, it's like, it doesn't know who Eric Jorgensen is, but there's been some experience where it's like already, I could spin up my own server and run the Stable Diffusion model, and I could add, you don't even need that much. It's crazy. It's like I could add, 5 pictures of Eric Jorgensen and just say like, hey, this is Eric. And it learns like what you look like. And then when I type that prompt in, it's going to show you, and it's going to be really realistic. And we'll start to see that like productized probably really soon.
Yeah, that's, I won't say too much about it. I have seen specific startups that are doing some really cool stuff with that early on, that they can like motion capture you and then make you do anything or let you do anything, which is going to get weird quick. I'm going to stop sharing my photo with you and everyone else.
It's weird. That's that kind of, I don't like talking too much about the negative side to it, because I feel like that gets plenty of airtime, and
that's not what we do here.
It's just more fun talking about the positive side. But there'll be a lot of crazy implications, but people over time, just like anything, they'll get used to it, right? I mean, right now it might be creepy when you're like, oh my God, like someone uploaded pictures of me and they put me in this image, whether even if it's not nefarious or bad in any way, it's still just kind of weird. But, over time you'll get used to it. And I think the example that I use is like, imagine the day that an Apple or Google actually productizes that, where, right now in your Google Photos or whatever, you're searching like, hey, show me pictures of me and my wife on our honeymoon or in Italy.
Yeah.
And it searches those pictures using computer vision. Once you add a feature like this in, then it's like, hey, show me a photo of me and my wife, like on the summit of Everest. And it will show you a photo of you guys like holding the flag up there where you got no human being can tell that it's a fake photo. That once it's productized, that's the level it will be. And, they'll have, of course, all sorts of protections on it, but it'll be like super like crazy when that happens.
Yeah, Facebook, Google, and Apple probably all have the data to do this today. Like they have enough photos that are tagged with enough things. That either they own or have access to. And it's so interesting how often like we have come up with the problem and the solution to that at the same time. Like I'm sure I can hear people shouting like blockchain solves this. Like the generation of images like to a ledger. I don't know. That is just like an interesting thing. Like there's ways to combat the nefarious pieces.
Adversarial models too. I don't know if I would call them adversarial, more of just like models to combat that. And you pass an image to it and it's just like, is this fake or not? There's some that are obvious, whether it's generated, but there are others where it's like, okay, was this generated or was this actual art? Was this digital art? Was this a photograph? And it would be able to tell you by like basically passing it through that model. So you'll get that too. And maybe that will become just as commonplace, on your iPhone or whatever, where it's like you pull a picture up and it just like now, Apple has the little info button underneath it. That's kind of like, does its intelligent machine learning on it. And that will be part of it. It will just be like, hey, this is fake or this was an actual photo or this was a photo and it was edited, things like that.
Yeah. Interesting. I think one of the things that, or one of the places that this is going to be most interesting to see, like the AI, especially the AI writing play out is around like Google and AI writing are going to have like this epic showdown. Because I feel like in some ways, like we are at peak content generation for SEO purposes. Like there's like half of Upwork is employed in order to like perfectly generate this content that perfectly nails keyword density and headlines and just all this bullshit, frankly, that's manufactured to like achieve a high valuable position on Google search. And I've seen people share early sort of like they're rough like models, but here's how GPT-3 answers like the same question, and here's how Google answers the question, and like it has the same cleanliness that early Google had against like the old shitty search engines. And so it'll be really interesting to see if the advance in like dialogue language and the ability to like pull the answer all the way out is actually going to be the thing that finally kind of like breaks the monopoly search or Google search monopoly. But at the same time, GPT-3 is also superpower for people to like totally fight the SEO content creation war, because it's now trivial to generate as much content to exact specifics as you want. Like, I don't know. It's going to be really interesting to see what happens.
Yeah. I mean, I think I've heard different arguments for people thinking that, either a startup or whatever is going to come along and disrupt Google. Like this is going to supplant Google's model, and others saying that, oh no, like Google will see this coming. It's not disruptive. It is, it's sustaining to their model, and they have, I'm not so sure, honestly, either way. Like I'd probably err more on the side of it's disruptive, but I can also see the other argument. It's definitely very different. I mean, I know, like, I remember within Google itself, they've had to transition over time to more of that kind of using machine learning and these newer models over time, because when Google started, they weren't using that, right? They were using other algorithms, and kind of companies get stuck on their ways. So I know they have already kind of transitioned to some degree, but that transition between like, I'm going to search and I'm Google and I'm going to crawl the web and I'm going to search this huge, enormous database of what's out there on the internet versus like, I'm here to help you, like answer your question. And, it can't be like GPT-3 right now is great, and you can summarize all sorts of things. You can ask it like, hey, how does a neural net work? Describe this to me like a 5-year-old, and it will explain it to you. And it seems like most of the time it's pretty damn accurate enough that, if you're, as long as you're not writing a paper on it, like you could probably trust it. But that's the problem, is it's not, even if it's 90% accurate, that 90% accurate is not even close to like enough, right? And then there's a problem that there's no references, right? It's like, you're like, well, where is it getting this data? Even if this is accurate, I don't know, where is this from? And so there have already been, like, they did something called Web GPT that is almost kind of like combines the large language model with the ability to search Google. So it's like, it's supplementing with Google, and there's just kind of giving the model essentially access to the internet. There's a company called startup called Adept, and I think, from how I understand it, their hypothesis is like, if we develop one of these large foundation models that essentially just uses the internet like a human does, but at a massive scale, then that's the road to like general intelligence. Because it's just like, that's what a human is. And it's like, if you ask, as opposed to GPT, where it's, again, you're not getting up-to-date answers. If you say like, what's the weather going to be like tomorrow? It has no idea. Whereas Google knows that information. But once you, a GPT level model with that level of understanding gains those abilities by either just using the internet like a human would, or being tapped into, connected to all of these different APIs, that's going to be super powerful. So you can say like, hey, GPT, like, what's the weather like tomorrow? Where should I go? Like, I'm interested to, I want to go on a road trip tomorrow, where it's sunny and it is less than 3 hours driving away. And it uses whatever website it has to. It doesn't need a database of all of these answers, or a model specifically trained to try to find travel related information. It just does what a virtual assistant would do. And if you asked, your assistant like to do that, okay, they'd look up the weather tomorrow, they'd look up travel times, they'd look up some like highly rated places, and it would do all of that instantly, give you back the answer in, an easy to use, like response. And there's going to be, a lot of that stuff coming. It's to the sense of, there's, over the last 10 to 15 years, there's so many companies, including Apple and Google, that try to do the intelligent, Siri assistant, and they just have failed. I mean, like, there's probably plenty of people that use like Siri all the time. Like, oh no, it's great. And it is, it's great for certain tasks, but it was not, I think, used as they imagined it, which is just like everyone using it all the time as an assistant. It's more used for like very certain things. And I think and so people kind of almost don't even like the idea of like assistant now, because like, it's like, that doesn't work. But with these, it's definitely going to work.
Yeah, it's one of those things that like, it hasn't yet caught on because it's just not quite accurate enough. And it's a frustrating, for some reason, it's more like the failures are more embarrassing with like a voice assistant or voice thing to say like, find me the nearest restaurant with a fireplace that serves steak, that's open right now. Like, that's either a 10 or 15 minute like web search, or it's instant given the right amount of information. But Siri couldn't do that right now. I remember being blown away by a Google demo maybe 5 years ago when they were showing some of their kind of like, call and make the reservation, but yet hooking up to a ton of APIs and having infinite data and enough intelligence to kind of parse that out. I mean, I don't think that's more than 10 years away.
I would say that's the like kind of stuff a couple of years away. Yeah. And that's the kind of stuff that, I will stop. You don't want to go to Google and get a list of links when that's your intent. You want, the answer and definitely references, and definitely accurate enough. But I think it's an interesting thing. And the spot that Google is in is like ultimate innovator's dilemma, right? Like they should be, they're one of the top AI, like they've got DeepMind, they have the best technologies in the world. The question isn't, can Google do it? The question is like, is Google willing to destroy, like eat its own search monopoly that is like the greatest cash cow the world has ever seen in order to provide a better user experience? Like, I don't know if they have that DNA. It's been 20 years that thing has just been like invincible. And if they earn a lot, I don't know, maybe they can find a better business model by being the API to the internet, and they can actually like
collect even more on that. But it's,
that's
it's
the
going to
question.
be
That's the ultimate question, right?
so
There's like,
interesting.
is the money? Is like, where does the money come from? And so it's like,
Yeah.
you know, if the money is against it, you know, if in trying to think about how they switch to that model, if they can't figure out how to transition SEO or, you know, or just selling ads in a way that gives them the same or more amount of profit, to your point, you know, that's where that's going to be the problem. If they can't do that, which based on just kind of thinking about it, like you just did, it seems harder to monetize, but maybe not. You know, if they can figure out a way to monetize it in a way that's just as good, that's very similar to just using SEO, where if you asked it like, hey, give me a restaurant, you know, within 10 minutes of me with a fireplace that has this meal, where it then kind of figures out how to feed, you know, paid results into that in a way that doesn't piss people off too much, you know, then I think then it's not disruptive, you know, then it kind of becomes sustaining to the business model and they can pull it off. But if they can't, if they're like, hey, like we can't figure out how to really we can make some money for it, but not as much, not as efficient as our existing model, which very much could be the case, you know, then it becomes probably really hard to make the switch.
Yeah. I wonder, I mean, if in a world where we are all sort of like browsing with a signed in wallet and like constantly undergoing micropayments for different things like that, maybe that gets really actually easy because you can unobtrusively monetize sort of the like transfer between all of these things. And there's still that kind of like live action auction thing that Google did for ads, but it's for direction of intention. Assuming you can attribute all those things, which will be some easier, some harder.
With the new models, though, if they train it to do that in that process, like you'll be able to. I mean, and so like you're saying, like you go to Google now and you just get a list of links. If you still want that for whatever reason in the new model, I think you could get it. You would just get that. I mean, and Google sometimes even does this now, right? It's like they have this summarization thing where it's like, if I search for, you know, some band name or whatever, it's going to give the name of the band, a picture, a photo of them, a little like one paragraph description that it has pulled from another site, and then it'll give you the list of the links. So it will essentially just be a much more sophisticated, natural version of that. At the bottom, there still might be a list of links of like, hey, if you want a bunch more, if you want to just kind of explore yourself and you don't want the one, you know, paragraph answer, then you can still do that.
Have you recently hired to like return to that, hired an AI for anything sort of in your life? I realize this week I literally started used Juggernaut AI, signed up for that, and so like an AI is now my personal trainer. Like programs all the workouts and sets everything, and like updates in between every set and every day, and sort of like works backwards from this thing, which is like, and does it for a less than 25% of the cost of and better, frankly, I think, because it can update more often and has a bigger database. And
how does it how does it know? Do you just plug in like what you've done every day then?
Yeah, so it onboards you through a survey, and it's like, you know, height, weight, lifting experience, strong points and weak points in each lift, what type of training and what your goals are, and then it generates a workout, and like sort of as you go, it says it works backwards from like rate of perceived exertion. So it says like, do this until you have basically 3 reps left, like that's the optimal exertion. And then it'll change weights and rep counts based on what you inputted, literally the previous set and your previous workout. And do your warm up and then take a quick, like answer 3 quick questions. Are kind of like, how are you feeling? Are your legs sore? Are your arms sore? Like that kind of stuff. So it's like micro adjustments within the day and the workout, but macro, I can see it's like training me for a test, like 6 months out, that we have like a program that we're working towards, like, you know, reaching certain goals on that date. And so it's really like, it seems to have all of the knowledge of a top tier trainer, and it has some education in there. It doesn't have the feedback loop yet that some of the apps do of like, take a video of this lift and watch the barbell path and give you personalized feedback based on that. But you could totally imagine, like, that's just a feature that exists in a different company that could totally get folded in. It's really, really interesting.
Yeah. I mean, add into that, like, the other aspect of having a personal trainer where it's like you have your AirPods in or whatever, and it's like, maybe not shouting at you, but it's like, hey, like one more, you know, that kind of, which I think you could easily do with all of those other things as prerequisites. So
yeah, you can imagine it. So yeah, definitely keep going. Oh, I would totally choose, like, you get to choose your workout partner. That was another thing we talked about recently, is like AI will emulate heroes who have big data sets that you can like upload them. And so I just want to hear Arnold like yelling at me while I'm lifting. Like I want that like co-pilot experience. That'd be awesome.
Oh, totally. Like you're weak, Eric. Like I can't believe you wouldn't do another set. Like it would totally, even knowing that like this is fake. Yeah, there's Arnold is literally not telling me to do this. Like I feel for sure I would be like, God, if he was here, he would be saying that. So like, yeah, I should do another set.
Yeah, I like that a lot. I mean, the same thing could exist in the combination of computer vision, AI, and then like output. You could have the same thing as like a cooking instructor, right? Like mount a camera over your stove, and it should be able to monitor stuff for doneness. And different sensors.
That's when all these
plug in.
Connected kitchen devices will finally really have their moment to shine.
Yeah, I mean, the kitchen has been left out of the smart home thing. We just invested in Ohm through Rolling Fund. It's like smart kitchen knobs. So one, it's a safety thing, right? So like if something's been on for more than 2 hours, it can automatically turn it off if you want that, or turn it down after you leave the house or something like that. Which is really clever. It's also a cheap way to retrofit an appliance that's expensive and annoying to replace. But it's a path toward the smart kitchen thing in general, where you could like coordinate a whole meal, preset it, automate it, like unburn things, or prevent things from burning.
I wish you could unburn them, but
burn things, throw them away, and start over without ever knowing and feeling guilty about it. It's just
you're like, what? Is it a throw? All why is there 3 pies in the trash can?
I mean, that's the Jetsons' rosy dream, right?
Yeah. You need the Tesla bot in your kitchen for that, I guess.
It's just going to look like but maybe kitchens get redesigned. I've seen some cool stuff where it's like robotic arms on sliders, and it's just like the whole kitchen design is along one wall, and there's like arms at kind of shoulder height that are able to like reach up and grab a pan and reach up and pull something out of the fridge that's mounted above it, and then it kind of like reaches down and does stuff on the counter. Like it's pretty rad. It's different than the like purpose-built giant like burger only factory that's kind of like the size of a McDonald's or whatever, but it's pretty cool. Yeah.
No, I mean that'd be an interesting one. I mean, I could see it be heavily used in industrial kitchens and whatever, where like you might still want a human and a few humans in there, chefs that know what they're doing, whatever, but just like massively assisting them. But I think the people who are like deathly afraid of AGI, like sentience sooner, they might not like it as much, but yeah, it's cool. They might not be the first early adopters to like, hey, I'm gonna take this robotic arm into my kitchen, but
no, they're gonna work at the cabinet factory that just has like a chisel and a hammer in it. They're nowhere near this. Right. This is another biology idea. I'm neck deep in biology ideas right now because I'm still finishing the book, but he's got a really interesting observation that, like, as robotics, kind of like a bunch of the stuff that we're talking about, as robotics takes off, it basically turns the margins that accrue to software are massive, and it just shrinks the gap between like proper instructions and energy. Like everything just becomes energy and output. Like all the creation in the real world is commoditized. And like in the kitchen example, the value becomes, how good is the recipe? As long as the AI can execute whatever it's taught, like the recipe is the magic, because the robot will just do whatever it's told. And then it's just a question of like how much like the robot gets amortized over time, and like how much is the energy and what are the other inputs, which I think is just a wild way to think.
But then if you keep going with that, running with that idea, Eric, and just like you said at the beginning of our conversation, where it's like the idea the biggest idea with computer vision is like you're trying to have a computer sense, right?
Yeah.
And a computer can't taste or smell now, but that's not impossible. You know, that's not crazy far off in the future. Honestly, there are machines, there are industrial kind of lab scale machines that do some level of taste and smell, but you know, there's not really any consumer use case or reason to bring it down. And it's just the technology is actually really hard. But that space, you'll see, it's like it's one of those kind of things that will all of a sudden, I think, within the next 5+ years, you know, take off and kind of seemingly come out of nowhere, even though there's been research on this. It's called like digital olfaction, like being able to, just like a camera sees, you know, having a computer be able to smell. And I think people, that's something that you're like, oh, okay, I guess that would be good. Maybe not. Like, what would that be used for? But it could be used for just like a crazy amount of things. I mean, forgetting about even consumer use cases for now, there are startups that are using it as you know, detecting COVID places so that you don't have to get tested. Just like dogs can detect COVID whether or not you have COVID. Like, this has already been proven, just as well as they can detect, you know, if you have certain types of cancers. And so that's because dogs' noses are, you know, insanely more sensitive to molecules in the air than humans. You know, does the dog know what cancer is? No, but it's like, it can smell that and it's like, hey, something is different. Some dogs can be trained to be like, hey, it's like, hey, this person has COVID. This is what this smells like. This is someone without it. And, you know, dogs are great, but it's like, it would be nice if we could have that in really cheap devices everywhere. Right. And so the next time there's a pandemic, you can feed that data in, distribute the model to every one of these devices in the world, and be like, okay, right. And just like you have dogs at the airport, security dogs, right? That they have like they have them run in, TSA runs them through to kind of just like pick out a random people and sniff them. But like, you would have devices put up, you know, through TSA or throughout the airport that's just like, I know what these certain things smell like. And there's a lot of things that have smells that people can't imagine because people's noses are actually really bad.
Yeah, that's super interesting. Like, the first thing that I thought of was like, oh, cool. It'll be able to like sense and smell gas just like we can.
Oh yeah.
Natural gas.
And that's
but also, like,
that's easier stuff. I mean, that's just like, you know, we have
super easy,
that in, you know, the basics of that in like carbon monoxide detectors. And I think, you know, the sensors that are in smoke and carbon monoxide detectors, it's kind of, I think those are just like really low level, easy versions of what I'm talking about. This is just like super advanced smoke detectors, basically, that detect certain molecules in the air. And speaking of which, this, you know, we've been talking about AI, this whole conversation. AI is like a heavy component in that, because you need to, once you can sense things, just like once you can see things out of a camera, you need, like, instead of computer vision, like computer smell, essentially, to be able to run these through the models and just like see, or help the computer understand what it is, quote unquote, smelling.
Yeah, it's fun. It's so interesting. I was going down the route of like, the computer doesn't have to taste in order to know that it's making something delicious, right? Because like, we know the combination of like ingredients and textures and temperatures with some reasonable certainty that it will like come out right without tasting intermittently each individual step.
Yeah.
The smell is really interesting, though. Yeah, and I had not considered all the things that are like, quote unquote, smelled, but sensed in the air.
Smell is so related to taste, though. It would essentially be the equivalent to the point where, like you said, if you had a robot that could bake, and like, you know, in your example, that literally could do everything, you could train the robot like to be like, hey, make me the perfect cake, chocolate cake, right? And it could just like, and you could give it, you know, these huge, I don't know, room-sized vats of ingredients, and just like have fun, like, you know, just iterate until you find me the best cake. And it can like, it would just make, you know, 1,000 cakes until it was like, okay, this is the perfect chocolate cake, you know, recipe that I found. So yeah, that's kind of a fun example, but you know, that's the kind of things that I guess would open up once the computers can kind of have all of the senses, basically.
Yeah, I mean, when they have the senses, I mean, we have some. I wonder what the most automated physical facility in the world is? Like, what is the factory that has the least human sort of interactions on a daily basis? And I don't know that. I bet the answer today is basically extremely, is relatively simple, like by percentage. But I think you said this earlier, like the vision into the manufacturing and the smell, like when computers can drive the full feedback loop, when they know when something's wrong, when they know how to fix it, the iteration and the like productivity that comes with that, the speed that like a fully automated facility can work at compared to one that relies on human intervention is insane.
Yeah. Yeah, totally. I mean, yeah, it's like it's one of those things that you can try to sit around and hypothesize and theorize about what the potential use cases would be, but it's just like, it starts to get really crazy really fast. And it's one of those things like, you just have to wait until it happens and just like see what people do with it.
Digitally, it'd be really easy digitally. I mean, you could probably take GPT-3, cut it loose on Twitter and say like, write a tweet every minute and optimize around like number of retweets. Like take the most retweeted tweets of all time, take those as the inputs, retweet it, like get as big as you can, as fast as you can.
Yeah. I mean, there might have been that already happening, and we're not even aware of it. So yeah, that's like
that might be Naval. Has anybody seen Naval in person recently?
Does he actually exist? Eric, were you the first to publish a book that was mostly written by AI?
That'd be really cool if I knew it, and slightly embarrassing if I didn't. Probably, yeah. Like I don't know what where we're gonna end up on the social conventions of this, but yeah, I actually think it would be really cool. Like I bet we will pretty soon see the first book like written by AI, or at least in collaboration with AI, and it'd be cool to have a conversation. I've seen conversations where it's like nominally would pass the Turing test. Like if you're just talking to a chatbot, you would not know that that's not a human. And the curated book length version of that might be really interesting. I don't know. It's probably worth playing with.
Even before GPT, people were like, writing scripts that just kind of go grab clips from Wikipedia articles and like haphazardly smash them all together into a Kindle book and like spin up like 200 copies of books like this and try to sell them on Amazon because like maybe 1 out of 50 of them will like sell a bunch of copies, and it's worth it.
Digital chips at typewriters.
Cost. Yeah. So yeah, I mean, I can't even imagine what it's going to be like with GPT, like plugged into that. So
yeah, I mean, it's really like the I'm starting to go down the reading rabbit hole of this too, and I'm reading Life 3.0. Have you read this?
No, this is kind of like is this the Kurzweil thing?
It's Max Tegmark's book.
Tegmark, okay, okay. I was thinking of a different one, yeah.
The first chapter or section or whatever is this like a narrative. It's a fictional narrative about the team that kind of first cracks AGI, or like to some extent, and it definitely like, they start over a weekend with like put it on a Mechanical Turk and like let it make $500,000 a day, performing like thousands of Mechanical Turk jobs in parallel. They were previously only humanizable, but are like doable by this AI that can train itself. And then the snowball just goes on from there. Like they start media companies, they're generating articles and blogs and texts and videos, like all sort of benevolently optimized for people, and to kind of like sort of bring them together. And it's like, it's a very sophisticated, sort of interesting fictional play-by-play of what goes. I don't know if it's posted online anywhere outside the book. I'll link it if I can, but it is like worth reading that book just for the first chapter of kind of like, oh shit, this is maybe how it could go and what it would be capable of. And I don't know, we see the puzzle pieces coming together.
Yeah, that's when you start to get into a little bit of some of the scary scenarios. But I think that reminds me of, I think it was earlier this year that Google, or maybe ex-Google engineer that thought that the Google model was sentient, the Lambda model, and it's like, it's obviously not sentient. Even if it's kind of at a Turing level, you can read some of the stuff that GPT or Lambda or whatever outputs, and it seems like, oh, I cannot distinguish whether this is a human. There's plenty of people who could distinguish whether or not it was a human. So it's like, it's obvious it's not even quite, seemingly to the Turing test level, although it's getting there. I think probably I've heard people discuss like whether the Turing test is a legitimate test in the first place. That's like philosophically way over my head, but yeah, I would think it's like for AGI, I think you probably have to see something like truly unexpected. If they programmed, they're doing these multi-mode like models basically that are not just text, where it's like the same. GPT is only text, right? It can do other stuff like can be translated to and from text, like code and whatever, pretty easily. But they have these multiple like mode models that the exact same model can output GPT like text, and it can do text to image, and it can do image recognition, right? And so that's like more along the lines of a generalized intelligence. But yeah, when one of those models, one day just kind of does something like just absolutely totally unexpected or defies their creators, and we haven't had that like HAL 9000 like I'm sorry I can't do that, Dave moment. Where it's like, no, you're programmed to do this, and it's like, no, I don't think so. Maybe that's when you can start thinking like, okay, now it's like getting to the point of, is it sentient? But that's another much
even if
more
it's just
complicated
obeying
discussion.
Ordered rules. Yeah, that's there's a lot of people who are qualified for that. I'm not one of them. You probably,
and neither am I. Yeah.
Long and frankly, like alternating between incredibly interesting and incredibly boring debates between AI alignment experts about all the different problems and scenarios and stuff. I just think it's really going to be fascinating to see how it all sort of comes together. I mean, the thing that humans like identify ourselves by our intelligence. Like we became like, I don't know, we're the most intelligent species. So we tend to see if we see a machine and we say like, we define it by things that can outperform us. And like now we're building things that are outperforming us, but they're still just tools, right? It's not like when we built something that could dig faster than us, we didn't start to question our humanity. And I'm not sure why intelligence should be that different from the physical piece, right? Like it might require a slightly altered definition of humanity because there's now tools that are more functional than us at like thinking tasks or however you want to classify it. But it's not, that doesn't make it life yet or maybe ever, but probably too philosophical.
We're getting
here for the tech.
Deep. Yeah.
So is there stuff that you see from the insiders, kind of like computer vision? You're in the computer vision industry, and now you're seeing all this like crazy stuff come out that's generative, which feels like the new piece, right? Not just like within the rules of a game, but openly creative. Is there like a huge new field of opportunities that you see now that you're paying attention to that you weren't before, and you're like, oh, there's going to be like a rush over there?
Yeah, I mean, just the generative AI, in general is there's been generative AI for a while now. It's just like only recently with this text to art stuff that it's really been so good that it's, completely like come into the public domain, and people are like, oh my God, this stuff is crazy. There's been, style transfer has been around for a long time. GANs would, many years ago would make like human faces that, this human doesn't exist. Basically, it was like creating a face from scratch. So like, that's all generative AI. But yeah, that's coming into the point where it's going to be used for so many different things. And even just the art stuff, it went from, seemingly not existing a year ago, to most people at least, to the point where it is now, where even the existing models, as they are, DALL-E 2, Midjourney, whatever, can probably replace jobs at the low end, for artists, contract artists or whatever that kind of would get hired for like, hey, can you, paint me a picture of this or do some illustrations for this? Like for sure, that's already happening. Or even just people And that's replacing like direct like money that people used to make.
The low end writers and illustrators, in the process of getting deeply disrupted, which is interesting. It's much more leverage for the users of those services, for sure. Like 10 to 100x cheaper and maybe better, maybe just the same, but 100x cheaper, the same thing is a huge win. So we sort of, once again, like incredible new tool and leverage, and some people who need to find some new work.
And just, things that are not direct one-to-one replacements, even just like making the people more creative. I mean, for sure, this is and will be a tool for artists themselves to make better art. No doubt about that. Whether it's like you're making something more complicated, or you're a filmmaker or something like that, and you're using it for ideas, like some of the Mid-Journey ones, like, the models seem to me to be better or worse at certain things, that they're not all the same. And, Mid-Journey seems to be particularly good at these kind of fantasy, like, digital art type illustrations and whatnot. And, some of those, like, I would highly recommend to, like, for anyone to go on, like, search, just go to Google and search like Mid-Journey showcase. And, that's kind of their showcase of some of the best, like the community's best generations. And, some of them are so crazy that, like, it's so obvious to me that someone who is in a creative field, and whether they're making a movie or whatever, can use that to, like, just generate creativity, whether they're like, okay, I've got a scene I'm doing or whatever, and they can use that, and they don't have to use the actual assets it generates. It can just be like, it can generate something like, oh my God, that gives me a really great idea. Just like the writing, like you mentioned, right? I mean, even if you, in Lex or Jasper or whatever, even if you don't use the text itself, just the fact that that's there and it's acting as your AI assistant, and it gives you extra kind of this creativity boost that you wouldn't have had otherwise. It would have taken you a lot longer to get or whatever. I mean, like you said, is there any that I've used? Well, I think in the last 2 or 3 blog posts that I've written, this was not with one of the tools like Lex or whatever. This was just me literally using the GPT-3 API, where I'm just kind of, I'll feed some, 2-3 paragraphs that I've already written in, and have it either continue those paragraphs, and if I run it through 10 times, 6 or 7 of those times, it's going to be, it's not gibberish at all, but it's more just like, oh, that was useless. Like, it doesn't really know what I want to continue. But a few of those times, if it's leading me somewhere interesting, it gets me to think. I'm like, oh, actually that's a good, or I forgot to mention that point, or, oh, wow, I like that turn of phrase. Like, I like the way it said that. So I'm not going to just necessarily even copy paste, but I'm going to use that to expand on that. And, for the images, it's the same thing. It's like, I used in the last post that I did on SpaceX, all of the images were generated by DALL-E. And first of all, I wanted to have them all be the similar type style, right? I wasn't just plugging in like, hey, show me a picture of a rocket. I wanted them to be all in the similar style, but they're not perfect, at least not yet. They're not. And so I usually went in with my iPad after and I made some edits to them. And, I'm not like the best artist or anything. So I can see just that exact same process happening with people who are amazing artists, and just like totally it acting as a multiplier on their abilities, and just like Photoshop did. And, this is no different than to me than an evolution of Photoshop. And when Photoshop first became really popular, in the I don't know, it was like the early 2000s basically, and then all of a sudden, like every single photographer was using Photoshop and retouching all their photos. I remember, but there was controversy. This was not like something that's like, okay, cool, we're just going to accept this. There were controversy like, hey, this is not real photography. These people are taking these pictures and they're modifying them, or they're taking pictures of people like models and they're like making them into these perfect, unattainable beings. But, eventually now that's normal. If you didn't use Photoshop, that would be really weird. It's fine. Like, that might be something that you can sell extra. Like, oh, hey, this is an art show for a photographer that, where it's just the raw images, and they go back and they do it in film, right? And that's great, but it's like, it's normal now to not do that. So
yeah. If my wedding photographer didn't use Photoshop, I would have been upset.
yeah, right. Yeah, I mean, it's like, who knows? Like maybe in 10 years from now, it will be like, if my wedding photographer or if my whatever like doesn't use, you know, one of these text an AI model to like make, or, you know, put me and my, you know, wife in some like awesome like fantasy-esque like photos where we're, you know, we're made of stars and we're in the universe and we're like, you know, whatever. It's like that could become the norm. Or
even as simple as like, hey, my Uncle Bob is like in the background not paying attention, make him smile. Like that could be as simple as
where you don't need to be a Photoshop expert to do that. I mean, that's like,
like AI could do that quickly and easily. I'm scrolling through the Midjourney community showcase now. I just Googled it and clicked the top link. It is like, they're beautiful pieces of art. And you're kind of like, if you didn't know what you were looking at, you'd be like, wow, these are like amazing, talented artists. The fact that they're like generated nearly instantly by a computer is crazy. But I also know, I've read enough about these, like, to know that usually these are the result of like a very nuanced, careful approach by the generator artist, for lack of a better term, to say like, you know, I want this and this and this in this style, but with this, you know, like there's some engineer, I think they call it prompt engineering. Like how do you place the prompt and how, so like when you generated those for your blog posts, like how much iteration went into getting something that you were happy with and like learning the skill of using this medium basically.
Yeah. And that's definitely a huge aspect of it. And, you know, I would call it, either calling it prompt engineering now, but to me, it's just like, it's, you're talking with the AI and you're like through this prompt engineering, you're figuring out how to converse basically with the model and how it works. But yeah, no, I mean, when I generated those images I had to kind of iterate to get the style that I was looking for. You know, I would get certain ones where I was like, I just don't, you know, it's not terrible, but I don't like the style or whatever. And figuring out these certain, whatever, these keywords that it has mapped to what I want out of it. And using those keywords, I'm like, okay, if I use these 3, but then switch out the subject for, you know, whatever it is that I want in the photo, then it gets this. But even then, it might not generate, I might not just press enter and it generates exactly what I want, right? It'll generate, the way DALL-E does is that it gives you 4 by default, you know, 4 different iterations. And even amongst those 4, it might be like, these are all bad. So I'm gonna generate, you know, I'm gonna generate 20 of them and I'm gonna pick the best out of those 20, and you can further refine that. So this is not just all of these amazing like images that you see on the Midjourney showcase. I mean, those are probably a result of that, right? It's not like someone typed in, and the great thing about the Midjourney ones is it gives you all the prompts that people typed in. So if you like hover over the images, it'll show the prompts. And, you know, for all of these, my guess is someone didn't just type that prompt in and press enter and this was the result they got. There was iteration. There was probably a lot of iteration in the prompt names. A lot of them are like more complicated prompts where they're adding all these other things in to try to manipulate it and get it kind of what they want out of the image. Some of them are really simple though. Sometimes people are just typing in like, give me a picture of the creation of the universe, where it's something that's kind of ambiguous, that there is, you know, there's only just total interpretations of it. And it just lets the model kind of run with it. And you can run that prompt, you know, 100 times maybe. And out of those 100, a lot of them are going to be crap where you're just like, whatever, like, you know, a 5-year-old could have done that. But some of them might be like truly amazing. And so that's the thing. Again, this is like, for people who haven't looked at this, each time you're generating an image, that's the first time you've ever seen that image. It's not like it's going into a database and pulling out a bank of existing images or pieces of other photos or illustrations. It is generating a new thing. Like the seed is new every single time. And so that's what's really truly kind of unique and crazy about them. And again, it's using that's part of the big controversy that we don't have to go too much into in this talk, but it's like, it's using images and art and photographs and whatnot from other people. And, you know, there's definitely obviously controversy around that. And it's like, should those people be paid somehow? And it gets complicated because it's like, look, I mean, I'll always remember the phrase, like, everything is a remix. right?
Yeah.
Everything is based off of something else you've done. Like if you're a writer, even you're obviously using the English language or whatever language you're writing in, but the way you write is like based on bits and pieces of writing that you yourself have picked up over your lifetime reading various things, right? If you only read, fictional sci-fi novels and you go out and write something, like you're gonna pick up like pieces of the style of writing that you're used to reading. And it's similar with images, right? So it's like, if everything is a remix, even with people, and I'm inspired by, Van Gogh's style of artwork into mine, like, does that mean I'm copying Van Gogh? No, of course not. It gets a little bit murky with these models because it literally is like using them as an input in the training process. But the art that outputs it is not from them. It just learns their style just like humans do.
Yeah, that was a part of the onboarding to Lex. Nathan was kind of, it seems like more clear of an issue in writing. I thought about it earlier when you said you really like to turn a phrase sometimes, like even a clip of language that the AI pulls, and maybe they pulled it from somebody else. And the onboarding warns is like there's the potential for some light plagiarism, depending on what your use of this article is. Like that may or may not be a problem for you, but there's really no way to know because it's pulling from so many sources. Sometimes it's generating its own thing, but it might be the same and you don't really know. It's pretty wild. But there's also like fuckers on Twitter who just like go around taking my viral tweets, copy pasting them word for word and posting them to their own. So like, it's not like this is a unique issue to human or to machines.
Yeah, totally.
If anything, it's at least an unbiased version. But you mentioned Jasper. I've seen. I followed the guy who started Copy AI for a while. I think Jasper's similar. I haven't checked that out, but they're basically. I think Copy AI like generates copy for you based on GPT-3 for like marketing and landing pages. You pay $49 a month and you get 40,000 words generated. And they are. I saw him just share like last week. They're at 10 million ARR 2 years into their thing. Yeah. And I think it's just like a really friendly, easy way to kind of, maybe they have some tweaks on top of it or rules or grammar checks or sort of a service layer. I don't know. But I mean, these technologies are turning into like real businesses. And I think cool stuff is getting built on top of these APIs. And we're going to see a lot more stuff like this in the next year or two. Yeah.
I mean, it's GPT as a model has been out it was released a little over 2 years ago. That was just the initial model. And then they probably have released it as an API out more and more. And people have been experimenting with it more and more. But, so it takes a little bit of time to kind of seep in. I think these image ones it seems like they're happening a little bit faster than normal. But yeah, it's going to, in the next 5 years, even with the existing models, you're going to see all sorts of crazy use cases. And again, it's just like these things take a little bit of time to be distributed and to seep into kind of the everyday things that people do. But you're already seeing it, like you said, generate a lot of revenue. And I can see some of these things even just scaling up faster. I mean, especially because in this case, the backbone they're using is GPT, and they're already able to just like scale, to infinity basically. And so if they're just using that as the back end, then it's way easier. It's way easier to scale. And maybe, the argument is that kind of, because they're using that as the back end, they're a little bit less defensible as a business model, but maybe there's other layers of kind of, competitive advantage that can be layered on top of that. I think that's probably totally dependent on the use case. I haven't given it a lot of thought for each of these individual use cases, but kind of what I was alluding to for Mashin, it's like, these are a little bit easier because it's software alone. When you start to get, industrial use cases like Mashin or Density, then you have a hardware component and you're selling to these huge enterprises sometimes. And it's like, there's that layer that's pretty, acts as a strong competitive, moat. But so it's a little bit easier for software, but I can see it's totally dependent on the use case. But yeah, we're going to see it on a crazy level from this kind of, whether it's these, what we were talking about earlier, the Google replacement to, whatever, just assistant for X. I've heard people already talk about, the legal assistant is like the obvious one. But whatever you're doing online, you can just like this is the super, this is the version of the Microsoft like Clippy in the corner that's like, but like the real one that's like really
Clippy
there.
And it's time.
It's time for Clippy to come back. And I really wish Microsoft would like release like a GPT version of Clippy that's just like, hi, I'm intelligent now. I can actually help you. No, but we're going to be seeing that.
I'm back, and I hate all of you for mocking me on the internet for 20 years.
Hey, maybe that's why Microsoft invested in OpenAI and is running all their training for them. So,
yeah, Clippy's back. All right. Well, if you're building a company that is based on any of these things, especially if you have hardware moats or data moats or distribution moats or service layer moats, like that's a thing that we might be interested in investing in. So please holler. We intended to also talk about nuclear, but we're 90 minutes in, and that was all AI. So maybe we'll do another episode on nuclear. So, any final recapping thoughts on the AI brainstorm session that we've had today?
I think that what I was just talking about is kind of the final is a good final word, which is just like we're going to be seeing a crazy amount of changes in the upcoming years. I mean, if you follow this even just like loosely enough, it's like it seems that something new comes out almost every week, honestly. Yeah. And again, these things that are coming out are not quite productized yet. The average person isn't going to go use them for the most part, but that's going to happen really fast because this is not. Yeah. This is not like 10 years ago where people were talking about self-driving cars. Like, oh God, there's all these self-driving startups starting, and like it's going to be like imminently we're going to have self-driving cars, and that's just like such a more crazy problem and another discussion. But it's these things are already to the point where they're basically the models themselves are ready to be productized and used. Just like you said, there's all these startups that are already using GPT as a backend. And same with Dolly. Dolly's they have their API in beta right now, and it's going to be crazy. You go on like the Nike website and say like, hey, give me this shoe or whatever, and it's like on the fly it generates this like crazy creative design shoe for you or whatever. I mean, you'll see it everywhere.
Yeah, there's a ton of opportunity with this over the short term. I think it's fair to say, like productizing them, applying them, helping businesses apply them, solving problems to create artifacts that need to be done. There's a million ways to kind of apply these tools like we're talking about. And I mean, what's also exciting over the medium term is what gets done with these tools, right? This is the classic, like technologies compound in terms of impact and progress. And this is a huge lever that we're going to be able to add. And I think it's not going to be long before AI is like helping us, I think it's already helping us discover drugs, helping us diagnose diseases, helping us analyze data sets. That
that's like we talked for so long about it, but we didn't even mention any of those other like more hard, hard tech real world applications of these models. We were talking about more of the fun ones, but that's like, and the advancements in those, in the last little while from DeepMind and others are just like crazy to think about. There was one recently that made matrix multiplication faster, which is basically that's how you train these models. Basically, it's matrix multiplication. So it's essentially kind of like the model is making it faster and more efficient to train other models, and so you can see where that loop is going. But yeah, it's crazy to think about all of the potential. I mean, you said we were going to talk about nuclear. We're not able to, but there's a model that helps control. There's many companies now that are working on nuclear fusion, and the fusion plasma needs to be controlled, and that's like a insanely physically hard thing to do. And DeepMind developed models that help control that like in real time and adjust the electromagnets to control the fusion plasma. And there you go. It's like that kind of stuff. It almost seems like it seems like neural nets and different types and structures of neural nets are almost they're turning into this universal problem solving method. Where the important part is like if you can phrase it in a way, you can phrase the problem in a way that's amenable to be plugged into a model like this and plug data in. then it will, back to like the fitness landscape thing, if you can format it in that way, then it will try to find the highest peak, and it's really, really good at solving that. And so I just tweeted about this the other day, where it's like, one of the explanations or reasoning that's given behind like the great stagnation of, our technical slowdown since the 70s is, ideas are just harder to get, right? We picked the low hanging fruit before that, and now it's just a lot harder. It takes a lot more researchers, a lot more time to discover something new and truly groundbreaking. But I'm not as extremely bought into that theory versus other things like energy and regulation or whatnot. But regardless, like, maybe it turns out that these models are really good at helping with that, at solving these problems and finding and acting as that tool to find new breakthrough ideas faster than if we could as just, a bunch of humans in a lab or whatever. And that would be pretty amazing if that just kind of really started to run away. And it's like, okay, first it's chess, then it's Go, then it's protein folding, which was pretty huge. And then it's matrix multiplication. And that could potentially just, again,
reactor
it's like
design. Yeah.
Yeah. I mean, the problem is just like, the problem for humans to do is just like, if you can, again, format that problem in a way that can be fed into the model, then it can hugely help solve the problem.
And these are like stackable skills, right? Like, you can imagine a model designed to generate prompts for another model that is designed to maximize like variety of guesses and attempts and brainstorms. And you can imagine another model that is designed to like fact check the output of that against like all of the physical laws and all of the design constraints and all of the material costs of different designs. And you could come up with some really, and all three of those, by the way, are like iterating at trivial expense massively quickly in parallel. As compute power and energy costs decrease, like is a really, really insane sort of thing that may lead to like breakthroughs in these other massively enabling technologies like nuclear and nanotech and space and which all things that you will be back to talk about more in the future, which I'm very excited to do. But
we gotta have a space episode for sure.
Yeah, well, maybe we'll do space next. I know you've done a ton of like research and have a ton of interest on that. But yeah, we could not let this get away without mentioning that AI is like a crazy variable, like a coefficient to the rest of the innovation supply chain, and can have some really, really huge impacts over the medium term on every other area that it affects abundance and costs of living and all of the things that we love.
It's going to be a huge industry too. It's like if it isn't already, I mean, it's more of a question of just like, how fast is it going to happen? To me, it's like, are we going to have another boom in the next few years where it's like some of these AI companies get, their valuations go insane and their revenue is going crazy, and just like all these resources are starting to flow to them? That's going to happen. It's just a matter of like how quickly that happens. I mean, you can already start to see it with some of these upcoming startups. And so, it'll be fun to watch.
Yeah. Very excited to have an oar in the water on that front, and see and get to use some of these tools. So, well, thanks for coming, Max. Thanks for taking the time. I appreciate this and enjoyed it as I always do. 100% go follow Max on Twitter at Max Olson and get his newsletter and stuff. And you'll be ahead of me and involved in the conversation because he's always sharing these really interesting things that he finds. And I don't know, we love batting these things back and forth. So thanks for hanging out.
Yeah, nice to talk with you. And hope to do it again soon.
Absolutely. See you in space.
Yeah, for sure.